Hey everybody, we're back with another C++ lesson with my son Alex. How's it going,
Hey
Alex?
everyone.
So today we're going to be teaching Alex about loops, and loops is a very important concept in any sort of programming that you're doing, no matter what language that you're doing. You're going to probably encounter loops. The concept of loops is that you're going to want sometimes to do something a whole bunch of times. Um, and today we're going to talk about that. So no matter what language that you're doing, whether it's Python, C++, JavaScript, you will encounter the situation of loops. And so I'm going to share my screen with you, and we will go ahead and get started. So first thing that I'm going to do is I'm going to bring up my iPad and try to explain this concept just in writing. And the most basic concept of a loop is if we want to take a number and we just want to add one to it a whole bunch of times. Okay, so let's say that we have this int, we'll call it num, and that we just want to take num and we want to add one to it, and then we want to take the result of that, and then we want to add one to that. Okay, so one way that we could do that is by saying num equals num plus 1. Okay. There are a couple shorthand ways in C++ that you can do this. One is by using the syntax n or num plus equals 1. Or another way that we could do it is by saying num plus plus. All of these mean the same thing, which is that num equals num plus 1. And you can also do this with minus as well. So you can say num minus minus, num minus equals 1, or of course, num equals num minus 1. Okay. Now let's say that we have num, and for whatever reason, we, like I said, want to just add to it a whole bunch of times. Let's just say we want to do it 5 times. So we would write this 5 times, right?
Hmm.
So num starts off at 0, and then we add 1 to it. So num will equal 1, then 2, then 3, then 4, then 5, right? Now there's a way that we can actually do this without having to write this a whole bunch of times. And this is with what's called a for loop. Okay. For loop is a way that we can actually take something and do something multiple times without having to manually do this. Okay. And there's a multitude of reasons why we want to do that in programming, and a lot of them that will become more apparent to you a little bit later in your studies. So the most basic one is just if we want to take this number and we just want to just take it and go from 0 to 5. So the way that the syntax goes in C++ is we declare the for loop with the word for, and then what we do is we create a variable inside these parentheses. So in this situation, in most situations, you will have an int, and then the convention is normally to call it I, and then we'll set it equal to something. In this case, we'll set it equal to 0. Quite conventional. You'll see this loads of times, hundreds, thousands of times, where int I equals 0, I is less than some arbitrary number that we pick out.
Hmm.
And then, so that's like a condition. And then we say I plus plus. Okay. And then we will have open brackets, then we'll have some code in here, and then we will close our brackets. So the biggest thing to understand is that the first time that you come to this line of code, what happens is that it first looks at what I is. So the first time you come in, it says I is equal to 0. And then we will look and it'll say, let's put 3 in here for this one. And we say it checks the condition. So this is like a condition. And it says, is 0 less than 3? So I is 0. Is 0 less than 3? And if the answer is yes, then we go into this code here, right? So the first time that I goes into this block, I equals 0. At the end of this, once it gets through doing its code in here, then it will do I++, which will do what, Alex?
It'll add 1.
It'll add 1. It will add 1 to I. So then it comes back to the beginning of the for loop. Okay, so it doesn't go past this, doesn't go past the braces here. It stays within the for loop. And then it says, okay, I now is 1. And then is I less than 3, Alex?
Yes.
Yes, because 1 is less than 3. And then it says, okay, if this condition is met, then we go back into the code. Okay, and normally you're doing something with I in here. You're adding something, or there's a whole bunch of stuff that you can do in here. And then at the very end, it does I++ again. So I was 0, I was 1, and then we're going to take 1. It's going to do I++ to that, which means that we're going to do what, Alex?
Add 1 again.
Yep. So what's I going to equal then?
Where were we at? 2?
Yep. So I will equal 2. So I is equal now to 2. Is 2 less than 3?
Yes.
2 is less than 3. And so you go back into the code and you do this thing again. And then it does its code. And at the very end, it does, it does I++. And so what's it going to equal then, Alex?
3.
3. Right? So I equals 3. And then is 3 less than 3?
No.
No. Okay, so once the condition has been met, it says, okay, now we're done, and now we can exit this for loop, and we can move on. Okay, move on. Okay, so that's how a for loop works. And what we'll do is we will show you how this actually works in code right now. Okay, so here we have a C++ program, and it doesn't have anything in it at the moment. And so, as I said before, we have the syntax where we declare a for loop with the keyword for, and we create a variable. Normally it's I, and we start it off at 0. I is less than, and we started off with 3. And then we say what we want to do with I when it's done with the loop, or when it's done executing the code inside. So let's say that we just want to print out what I is. And We see we got a build succeeded, and we have 0, 1, 2. Okay? So a couple things to understand about this code here. First thing to understand is that I is only local to the for loop. Okay, so you can't use I anywhere else except for inside that for loop. Okay, so if I just took this line of code and I copied it, and then I just comment this out for a moment, you'll see that I've declared this int I, but you'll see down here in line 17 we have an error, use of undeclared identifier I. That's because I is only local, it's only used within this for loop. Okay, so that's what we call scope. Okay, so the scope of I is only inside the for loop. Okay, and that is what we have there. Okay, now what we could do is we could take and we can say int num equals 0, and in here what we could do is we could say num equals I, and then if we see out num at the end, we will see that num will be 2. Okay, so we could do something like that. But there's loads of different stuff that you could do here. Okay, loads of different stuff, and what we could do is we could say num plus equals I, right? So that would be interesting. Okay, so what do we have there, right? So let's have a look at. Let's go back to our iPad for a moment and let's analyze this before we run our code. So I will do a new page. So we have this num equals 0. Then we have this for loop where we have I. I'll just write the whole thing out. So for int I equals 0, I is less than 3, I plus plus. Okay. And then in here, we will say num plus equals I. Okay, so let's have a look. And when you go through these things, the biggest thing to understand is that you just want to go through it one line at a time, right? So num is equal to 0, and then we have for int I equals 0, and then what happens from here, Alex? So let's walk through this together.
So from the top.
Yep.
Okay, so it's going to take, it's going to say num equals 0. Then in the for loop, we got a new variable int I equals 0. I is 0 and therefore less than 3, so it's going to go through with the actual body.
Yep.
We're going to see, okay, so num is equal to 0, and num is going to be defined after it's added to I. So in this case, I equals 0, so num doesn't change, it's just 0 plus 0.
Yep.
Right. So then it goes back and it says, okay, after we add 1 to I, now I is equal to 1, 1 is still less than 3, so it's going to go through again. Now we got num plus equals 1, 0 plus 1, which equals 1.
Yeah.
Then it's going to go back, and now I equals 2. 2 is still less than 3, so it's going to go and add 2 to num.
Yep.
And then after it hits 2, it's going to redefine I as 3. And here the loop stops because I is, 3 is not less than 3.
Yeah, exactly. So yeah, so that's exactly right. And yeah, as I said before, there are loads of different things that you can do. With for loops that you'll do with them in the future. And what we could do is we could actually just take a look here and we'll do a little C out. And we will do num. And let's just print it out. And we see that we got those right results, 0, 1, and 3. So let's see. And the nice thing about I is that you could do this like loads of times. So if you want to do 100 times, okay, so we see that it will do it for us 100 times, no problem. In a split second, it'll do it. If we want to do it 1,000 times, it'll do it for us, no problem. So see, that's the nice thing about this is that it will just take it and it'll just do it. And it doesn't have to be I plus plus either. It could be I plus equals 100.
I just realized I was slightly wrong.
What's that?
Because I think I said initially that it would be 0 plus 1, and it'd go from 1 or 0 plus 2, but that's actually wrong because num would be redefined as 1, so it'd actually be 1 plus 2.
Yeah, which gives you 3. You got it right though.
3.
Yeah, you did get the answer right though.
Oh, okay, fair enough.
Yeah. So like I was saying, like you could do I plus equals 100. You could do I is less than 1,000. I doesn't even need to be 0. I could be 10. I could be anything. But it's just when you want to take something and you want to execute it multiple times. Okay, so that's for loops. Okay, any questions about that?
No.
No. Okay. So now let's talk about while loops and do while loops. So the concept of while loops and do while loops and for loops is actually quite similar. It's pretty similar. The main difference that I would say between a for loop and a while and do while loop is that in a for loop you typically know how many times that you want to do it. So you typically want to do it, when you have that condition in the for loop where you say for int I equals 0, I is less than, this value. So this value really defines how many times you want that loop to do something. Okay. And that is the main difference between a for loop and a while loop. So a while loop is declared by using a while statement, and then what it does is it says if this condition is true, then execute the code inside. If not, then we will just go straight to line 18. Okay, so one situation is, let's say num is 0, and let's say while num is less than 100, then we could say num plus plus. And then what we'll do is we'll print out what num is each time it goes into this loop. And so what we'll see is that we get a similar result to what we have with the for loop. Okay, so it's difficult to create a condition where the condition inside is an unknown quantity with such a simple example. So then you have this other type of syntax, which is called a do while loop. So do while. And these two are very similar with one significant difference. So let's see if we can create something here. So we got num plus plus, and then we'll do something similar here. Num is less than 100. Okay. And the biggest thing to understand between a while and a do while loop is that a while loop is that a do while loop will execute once no matter what when it comes to this code. So when it comes to line 20, it will do the num plus plus before it checks the condition. Whereas the while loop without the do is it will check the condition before it adds, before it goes into the braces. So the biggest thing to understand about a do while loop is that a do while loop will execute at least once. It'll always execute at least once before it checks the condition, whereas a while loop will check the condition before it actually executes. Okay. Any questions there?
Yeah, so I noticed a very subtle difference between the while and the for loop. If we had made a loop similar to this with the for, it seems like it would have actually ended on 99
Uh-huh.
because at the 99th iteration, I would be equal to 100, and then at that point, 100 wouldn't be less than 100. But in this case, because it's not, how do I explain? It's not relying on num being 100 or less than 100 to actually start the loop. So after at the 99th iteration, it says, okay, 99 is less than 100. Then it'll add one more, and then the loop is over.
Yeah. So let's have a look. Let's have a look at that. So that's a very good point. So yeah, exactly. So you see that it actually ends with 100 because it doesn't check, as Alex was saying, it doesn't actually check that 100 is less than 100 until after num plus plus. Whereas with this one, it actually ends at 99. Right? Does it?
I think that was a for loop. Well, we never actually made a for loop, but
yeah. Oh,
hypothetically,
when we made the for loop, yeah. The for loop would stop at 99. So yeah, because what'll happen is that 99 will be in the last iteration on this one. 99 will be less than 100, and it'll do num plus plus, which gives us 100, and that's what we end up with. Whereas with a for loop, so let's do a for loop now. For I is less than 100, I plus plus, and then I, and I will get rid of all this. Oops. And we see that we end at 99. Yeah, so as you can see, as Alex pointed out, there are subtle differences here between the for, the while loop, so while, and also another thing is that while involves something that is external. So well, I guess they all do, because with the for loop, you wouldn't really be able to do anything useful without having something outside of it that you're doing with it. Right. But in this one, we have to declare I, and then we have to say while I is less than 100. And then in here, we would say I plus plus. And then the do while loop, once again, just doing the syntax for that. Got do I plus plus while I is less than 100. So there you go.
So, when we were talking about how in the for loop, just for example, the variable is initialized within it, and it's only applicable within the scope
Yeah.
of the for loop.
Uh-huh.
So, and that's why you redefined I as 0 after it, because then that would actually be in itself within the scope of int main.
That's right. Yeah. So like we were saying before, this I is actually just within the scope of this for loop, whereas I on line 17 is actually a whole different I that is within the scope of int main. So
But the reason why I brought that up is because that means you could actually have a for loop that isn't I. So you could have, I don't know, I can't think of an example on the fly, but maybe there's a situation where it's not I specifically, but maybe you need a different variable to change.
yeah. So well the big thing with the for loop is that you're always declaring well, there are exceptions to this with like what we call range-based for loops, but in this particular type of context, normally you're declaring a variable that will only have the scope within I.
Right.
Okay,
Okay.
so there are other types of for loops that where using you're not actually using numbers to iterate through. You're using actually different things, but that's something for a little bit further down the line, and I don't want to confuse people.
Fair enough.
But
Okay.
but yeah, so anything, and it's important to understand that anything that you declare within the for loop is only going to be local to the for loop. So it will not exist outside of the for loop.
Okay.
Okay, so if I have, an int j equals 10, and then I said j plus equals I, then j will not exist down here. So if I try to access j, we'll get an error, and it says use of undeclared identifier. Okay, but if
Okay.
I tried to do that within the for loop, then it works fine because it's local to that scope.
I see. Okay. And then my last question.
Yeah.
We kind of briefed over this in the if else episode, where we talked about a condition which would result in impossible or in infinite results. So I
Mm-hmm.
guess an example of this would be um, int I equals 0, I is less than 100, and then I minus minus. So that would be infinite because I would never go above, uh, or I'm sorry, I would always be below 100.
So say that one again.
So if we changed I plus plus I minus minus,
Mm-hmm.
then I would always be less than 100 and therefore making an infinite program.
Yeah, that's right. Yeah, so if you went and you changed this to I minus minus, then that's correct. Then I would just continue forever, and this would just probably freeze or crash. Another one is what we call well, I forget what the name for it is. I don't even know if it has a technical name, but I was going to say recursion, but this isn't recursion. But one where you might say, okay, I is less than 100, I plus plus, and then if you said if I equals 99, I equals 0.
Oh, so it resets it.
Yeah, yeah, exactly. So something that resets it. So we want to use a double equals here because we're doing a comparison. So something like that.
So don't see it giving you a warning, so you got the wrong curly bracket.
Oh, yeah.
Now, this is kind of outside the scope of this particular lesson, but I heard somewhere that there was some way to change the compiler so it'll actually uh, have a certain level of strictness with the code. So I don't know if this applies directly to Xcode, but so for example, in this case, if you had the level on max strictness, whatever that means, then it would actually detect these very small, subtle errors. I don't know. Like I said, I don't know if that applies specifically to Xcode.
Yeah, I don't know if I don't know if any compiler would actually catch a condition like this, but there are certain types of things that you can do with compilers and make rules if uh, where if you have any errors or any warnings and not ones that are errors, so like one like this, int I equals 0, and then I don't do anything with it, you'll get a warning that'll say that I is unused. So some people actually create rules with their compiler where and where you won't be allowed to have any warnings, and any warnings will be treated as actual errors.
Okay.
So so things like that. But I don't know. There are certain times where the compiler will give you a warning if if a condition, if something, like for example with an if statement, sometimes you'll have one where it'll say for one reason or another this condition will never be met. You know, like what we saw last tutorial where we were trying to say if 100 is greater if 100 is greater than 99, and it 100 will never be greater than 99. So yeah,
Okay.
cool. Any other questions?
No, that's it.
Okay, cool. Well, there it is. Very important day in your career as a software developer. So, so yeah. So I hope you remember this day.
Yeah, definitely. Or else I'll be down the line struggling with them.
Yeah, great. So that's where we're going to end this tutorial. And if you enjoyed this and you found this helpful, please be sure to like and subscribe and all of that good business. And we will see you for the next tutorial.
All right, see you.
See ya.